Let's look at problem 560. So subarray sum equals K. So here is the problem. Given an array of integers, numbers, and an integer K, so we return the total number of subarrays whose sum equals to K. So a subarray is a contiguous non-empty sequence of elements within an array. So here are two examples. For example, if given 1, 1, 1, so K equals 2, then the first two elements as a subarray sums to 2, and that the second and the third one also sums to K. So in this case, there are two subarrays whose sum equals 2. So in example 2, we want the sum to be 3. So it's either 1, 2, or 3 itself as a single element array. So we can look at some of the constraints. First, the length is up to an order 10 to the power 4. So in other words, if we want to solve this problem using brute force, it might not be working. So the other two basically about the elements in the array. So in order to have a better understanding, we can look at some other examples. For example, if given a numbers which is let's see, this one, 10, 2, -2, -20, or 10. So as you can tell, this 2 and -2 cancels, so they add up to 0. So some examples of subarrays which sum to let's see, the target is -10. So in this case, some arrays like say 10, 2, -2, and -20, which gives you -10. Also, we can see if we do 2, -2, -20, and 10, it also gives -10. Also, we can examine -20 and 10 because this 2 is essentially giving 0. So in this case, we have 3 subarrays which give us -10. So another example, let's see, 9, 4, 20, 3, 10, 5. So you can see none. So the target, let's see, K is 33. So the first 3 elements is sum up to K. So 9, 4, 20 is one subarray. Also, we can check that 23 and 10 also gives you 23. So in this case, we know actually the number of subarrays and their element with sum equals 23 is 2. So we would like to see the solution to this problem is similar to the classic two-sum problem, or to the problem which check if there are subarrays with sum equals to say K, or is a multiple of K, as problem 523. So now let's see the main point of this problem. Main idea is using map or dictionary to record some partial sum frequency. Right. In other words, we count a partial sum. For a partial sum, we count how many times it appears during our scan. So the main idea is still the same. So if we have a subarray from 0 to I with a sum Si, and you have a subarray so from 0 up to index j with a sum Sj, so the subarray from I plus 1 ending at G has sum Sg minus Si, right? So this is the main problem, main idea. So I would say this is similar. This can be regarded stemming from the classical to sum problem. So let's give a solution following the same line of idea. So let's see. The first step is to initialize a dictionary. So in order to deal with the case, because originally there's no partial sum, we start it with 0. So 0, the correct default for it is 1. It appears once. So we start this as, let's see, previous sum. So it's a dictionary. So let's assume here appear once. So here this is the partial sum and the frequency pairs. So with this step, so let's initialize a result, so which is the count of subarray with sum equals to k. Now we have a running sum, so it's current sum. So it's 0 before we start. So now let's scan the numbers. So for y in numbers, so the running sum updates to current sum plus y. Right? So now we want to check if current sum minus k appeared in the previous sum. If so, we get a number of subarrays with sum equals k. So if this guy is in the previous sums, which means the result is updated to previous sum at this number. So this is an increment in the result. So the idea behind is this: for each of the counts in the previous for this k in the previous sum directory, so each account corresponding to a previous index. So in other words, from index 0 to up to that index, we correspond to a subarray with sum equals to current sum minus k. Then the current sum represents that from index 0 up to this index corresponding to y, it has a sum equals current sum. So the subarray in between has a sum which equals to k, right? So then what we also need to do is to update the previous sum, because current sum appears. So we want to update that like this. So if current sum in the previous sums, we just need to update the frequency by 1. So previous sums, current sum increased by 1. Otherwise, so we just set this frequency equals 1. So once this is done, so we can return the result. So we can regard this as step 2. So update and count. So finally, we return the result. So let's try a test. So this passed this one. And also it passed. So basically, this is a linear solution, because accessing a directory key, check the frequency is O1 operation. So that's about it. Thank you very much.